Imagine window blinds that breathe like a plant. No motors, no sensors, just changing shape when the air gets humid. Finally, something in a building that moves without a firmware update. Heating and cooling buildings burns a lot of energy, and a big driver is sunlight. Sometimes you want to block it, sometimes you want to let it in. Most smart shading systems use motors, controls, and maintenance. That adds cost, failure points, and complexity. Nature already does automatic movement with no batteries. Think pine cones. They open and close depending on humidity. That's because plant tissues swell when they absorb moisture and shrink when they dry out. They 3D printed a two-layer strip, a bilayer. One layer swells with humidity, the other resists. When the air gets humid, the swelling side expands and the whole piece bends. When the air dries out, it relaxes and flattens. It's like a bimetal thermostat strip, but instead of heat, it runs on air moisture. They used a cellulose-based composite for the moving layer. Cellulose is the main ingredient in plant fibers, and a UV-resistant plastic layer to hold it back. They designed small, flap-like shading modules for a real building facade in Germany. In summer there, days are often hot and drier, and nights are cooler and more humid. So they tuned the geometry so the flaps flatten and block sun when it's dry/hot, and curl open when it's humid/cool, letting more light and warmth in. In the lab, they checked how the bending changes with humidity and temperature. They also stress-tested durability. The material actuated for 170+ humidity cycles, and UV exposure didn't ruin the behavior in the way that matters for shading. Then, they put the modules into a facade mock-up and watched them respond to real weather for over a year. In summer, daily humidity swings drove big motion, closing to nearly 90% shade coverage during hot, dry times and opening to around 50% during humid nights/mornings. In winter, it stayed mostly open because winter air was typically more humid, helping allow sun in when you'd want heat. This doesn't magically solve building energy use by itself. The paper doesn't claim measured energy savings yet, and the system is designed to be protected from rain while still sensing outdoor humidity. This is the kind of biomimicry I love, boringly practical. Use cheap, abundant material plus smart geometry and let physics do the control loop. Motorized blinds. I require electricity and maintenance. Humidity blinds. I require vibes. Would you trust passive plant logic like this on your home? Or do you only trust systems you can manually override?